Hey folks, hope you all are doing well. I'm Karan Bandal from Econosite, and in this video, let's talk about India's chip making ambitions and the China challenge. What is a chip, anyways? It's actually a semiconductor chip. We often just call it chip. It's a tiny electronic device that consists of small piece of semiconductor material, typically silicon. From modern day computers, smartphones, cars that we drive to medical devices, they all need chips. Imagine a circuit board full of electronic components such as transistors, diodes, resistors, etc., interconnected to perform specific functions such as data processing in a computer or controlling the operation of a device. Now imagine that circuit board miniaturized to the scale of nanometers. Nanometer is 1 millionth of a millimeter. You can't even see individual electronic components. That is a chip. It's a very crude and simple explanation, may not be fully accurate, but it's a good starting point. Chips are the building blocks of modern electronics. Chips have enabled the development of smaller, faster, and more energy efficient electronic devices. And in this space, India excels as usual in services. IC or chip design capability is India's greatest strength. India has roughly 300,000 design engineers. The country has produced roughly 20% of the world's IC design workforce. It's quite remarkable considering global industry still has shortage of design engineers. What India has lacked in is the chip making capability. Fabricating semiconductors is perhaps the most complex manufacturing activity humanity undertakes, according to the US-based think tank ITIF. So if India is to make progress in chip making, it very well may need at least a decade-long, uninterrupted effort both from the private sector and on the policy front. And some encouraging developments are now taking place in this regard. In 2023, US-based Micron committed to invest around $1 billion to build semiconductor factory in the state of Gujarat in India. Its construction has already begun. The factory is expected to come online by the end of 2024. The total investment, including the state investment for this project, is around $3 billion. It gives us an idea of the scale of investment needed for just one such facility. Then about a month ago, another 3 major semiconductor projects were announced. The total investment entailing them is over $15 billion. 3 new semiconductor plants will be built, one in the northeast of India and 2 in Gujarat. In all these projects, Indian firms are collaborating with the foreign companies that are known for their chip making capabilities. All these projects are expected to create in India the capacity to produce about 19 billion chips per year in a few years' time. Keep this number in mind. These projects are also expected to create over 80,000 jobs. These are some solid gains that India is going to make in chip manufacturing space, but we need to temper the excitement. Because first, through these projects, India's most sophisticated output will be the chips built on 28 nanometer process at best. These are commonly used chips in general purpose applications, also called legacy chips. The smaller the chips, the more valuable they become. I'm talking about the chips that are 7 nanometers and below, which are high-end data center AI chips. Since India won't be making any of these in the immediate future, it will miss out cashing in on the current AI boom. And second, there are multitude of challenges. India will have to create a business and policy environment where a deep and vibrant semiconductor ecosystem gets fostered, not just in one area, but starting from semiconductor production, research and development, fabrication, packaging to testing. It needs to enable the creation of a network of suppliers and supporting institutions to keep the industry cost competitive yet innovative. Only then the investments will keep on coming. Semiconductor factories need a dependable supply of water and power. Power outages can in fact damage the equipment and the chips that are in production. So quality infrastructure support is vital for success. Then India does produce many chemicals required for semiconductor manufacturing but lacks refining capacity to boost their purity levels to semiconductor grade. That's one more thing India may have to depend on China. And finally, there is the big China challenge. Squeezed by the United States in its access to cutting edge chips, China is pouring money into legacy chip making at a breathtaking pace. Remember what India is going to make with its new projects? Legacy chips. Now go back to the number I asked you to keep in mind. Against India's total future manufacturing capacity of roughly 19 billion chips per year, China in 2024 alone is going to add the manufacturing capacity of around 60 billion chips per year. In other words, China is going to add in 1 year more chip making capacity than the rest of the world combined. 1 million more wafers per month. Undoubtedly, this is going to compress margins for everyone, especially for new players. Chinese government's incentives of over $150 billion will help producers there absorb losses, but India does not have such deep pockets. What India has is its unique ability to offer a marketplace for consumers and businesses alike. India's expected compounded annual growth of 14.6% in the disposable income over the next 3 years and its tech-literate urban middle class will ensure that India-made chips will find quite a few buyers in the domestic market itself. In summary, India is good at designing chips, not so good at making them. The new government incentives, coupled with a fast-growing consumer market, has begun to attract some chip-making investments in the country. Such policy efforts need to sustain if India wishes to overcome the multitude of challenges in its path towards becoming a leading chip-making nation, especially the China challenge. I hope you found this analysis interesting. I'll speak with you again next week. Until then, take care.